Hey guys, so today we've got something a bit different, not a Tektronix. And if you've been on the internet as long as I have, at least on the technical side of the internet, I think you might know somebody by the name of Tom Lipton. He runs the channel Ox Tools, and he's a really cool machinist, sort of like an uncle kind of character. He's really nice, and he's very accomplished in his work and craft, and um, I kind of look up to him a lot. And a while back he did a video about how thick is a Sharpie mark, and I don't really have Sharpies, but I have these things. And he had some crazy, very fancy dial test indicator, microcator or something like that, on a very fancy lapped, uh, measuring base and stuff like that. And he measured 3 colors of Sharpies. I have one color of Bic markers, and they turned out to be about, I think, if I remember correctly, somewhere around 20 microns thick. So surprisingly thick coat. I'm pretty sure that's a patented recipe of Sharpie, optimal visibility. And what he used was that dial testing indicator, a set of gauge blocks, and that was about it. So I got kind of the same setup. This is a granite measuring plate with a dial test indicator holder on top, and this is a tiny box that's meant to read out the readout of this thing. So this is a linear variable differential transformer. It's a very precise linear displacement sensor transducer, and it's got a readout system in here with some Sony ASICs and stuff like that. And I made a tiny box that's got a Infineon microcontroller inside, and it just reads out the data from the thing. I used an Infineon board because for example, the XMC 4700 in here has a very powerful encoder peripheral, so it can read out encoders at very high speeds, and it also has a lot of features, and it's very idiot proof. And a friend and coworker who had already written the driver for these 16:2 LCDs helped me put together the rest of the thing. I kind of got it working, and he kind of fine-tuned it, and I put it in a box, and it now works. By the way, this is a present that I got from a friend. Hi, Razvan. And I think you know him. He's been on one of my Talking with Friends discussions. So let me tell you a few facts about this thing. So this is made by Magnascale. And if you don't know Magnascale, they make the readouts for DMG Mori. So pretty much the bee's knees. And this is a kind of just a basic cheap granite plate. But the LVDT basically is a transformer that has a primary and 2 secondaries and a moving magnetic coupling core that basically, the more it moves, the more it couples a signal into one or the other of the windings, and this thing reads it out and just outputs it as a bog standard AB encoder output. This is 100 nanometers resolution. I'm hiding one of the digits here, not because, I don't want to get as many digits as possible, but because that digit really is just resolution and it's not accuracy. So I don't know how trustworthy that last digit is, and 1 micron of resolution is really ample for this application. You can also see that it's blazingly fast, so it's not only very accurate, but very repeatable. So I can click it back into its place, and it goes back to 0 quite repeatably. I'm just barely touching it, and I can get 2 microns of movement So let me show you a few things. So this is a set of Soviet gauge blocks, and that didn't pan out as good as I wanted. I was just gonna say, how does that get here? But anyway, so let's pick a gauge block. And I don't know if you know these. These are highly precision machined and lapped components. These are kind of worse off for wear, but they still ring together. And what is ringing? It's when you take two of these and you kind of push on them a bit. And if they're good, they're gonna, stick together. There's a lot of discussions about why and how they stick together, but most of them still ring together. So I would call them decent. This isn't a very high class of gauge blocks, but a flea market find, so price was right. So I'm gonna put it here. Of course I warmed it up, and I'm gonna rub it into the granite plate a bit, because the film of air between the granite and the gauge block itself is enough to skew the results. I'm gonna move this under here, and you can see that if I push it down a bit further, it's 7 millimeters and 6 microns ish. Not great, so it's 6 microns off from its nominal, which is probably within its grade. But it works, and this thing is really darn accurate. So what do we do about this now? So my plan was just, and I'm gonna do this live so you don't accuse me of having cuts or anything like that. I'm gonna take this out of here gently. Try not to warm it up too much. I'm gonna put it on here so it stays relatively at the same temperature. I'm gonna grab if I can, one of these hemostats, and I'm going to mark one of the sides with some Sharpie. Gosh, well, something is magnetic here. I don't like it. So I'm just gonna draw some crisscross patterns. I should have zeroed the indicator first. And now I'm gonna flip it over carefully, not touching the gauge surfaces. And I'm gonna quickly wipe most of it off and move it back under the thing. So that was a failure, because you can see most of the marker remained on the granite plate. So let's try that again, but I'm gonna do it differently. That one's too warmed up by my hand now, so I'm gonna get the 5 millimeter one if I can find it. I think it's this one here, and I'm gonna put it here. Oh, you know what I just did, right? I forgot to zero it. It's late, I'm tired. Don't yell at me too much. Okay, so let's put it under here, zero it. Oops. Pretty darn close. Oh, by the way, you zero it by pushing this button. So off you come. We're not going for bluing result here, but it should be dry enough right now. And it's 8 microns. Let me see if I can get it a bit to seat a bit better. Okay, so I'm not gonna touch it because I'm gonna just start warming it up. So it's about 5 microns, 5, 6, maybe 7. It depends, it's very finicky. But you can see this thing can totally measure the thickness of a Sharpie. Now, what am I gonna do with this? Well, I'm building a CNC. I actually got first chips today, and I made a very nice little part out of Teflon that I cannot find. Just a test, but anyway, this is gonna be, so the LVDT is gonna serve in me showing how straight and accurate and true the machine is on all axes. I'm not a mechanic by any stretch of the imagination, but I do know a bit of mechanics. So I can comfortably operate a CNC machine without crashing it too many times. I can pretty much design almost any sort of component level thing in CAD, and I have a reasonable understanding about, you know, fits and measurement and stuff like that. But I'm not a mechanic by trade or by education. And the CNC is gonna hopefully help me turn into a bit more of one of those. Yeah, so that's about it. Let me just get another gauge block so I can show you just how not great these gauge blocks actually are. So this is a 10. I should have zeroed it again. So resting on the surface. I'm pushing it against the granite plate so it rings with the granite plate itself. And yeah, this one's 4 microns off. Pretty good, all things considered. So for less than 30 bucks for the full set, and they're still in decent enough condition that they still ring together. Yeah, I'm gonna clean this with acetone. I'm gonna oil it a bit and put it back, and that's about it. A very short video. I'll keep you posted. CNC is officially fully operational. It just needs a bit more, you know, finishing touches, but I've configured everything. Tool library is up, Linux CNC is up, spindle is up. Found a very nice way of controlling the spindle with one of these. This is a PWM to 0 to 10 volt converters. It's just got a basic filter and op amp, and it takes 24 volts in, which I have in the control box for the spindle, and you stick a PWM in it, a kilohertz, and the duty cycle basically changes the output voltage from 0 to 10 volts. It's just a basic, it's like a filter for a PWM DAC. That's basically it. Yeah, you know what I mean. And it works really well. Like, Mesa card sticks into one side, PWMs it, and the 0 to 10 volts just feed into the spindle drive. So that's about it. Hope you enjoyed it, and I'll catch you next time with some more stuff. Maybe Tektronix, maybe not. Take care. Bye.